Hi, kids. My name is Claire, and my friends Daniel and Luis are going to teach you about chemical weathering today. Have you heard about geology? Geology is the study of the earth and its processes. It's important we study geology because we need to understand our planet and home. One of the most important aspects of geology is weathering. Weathering is the breaking of rocks, which is critical to the field of geology since our planet is made up of rocks. There are two types of weathering that can occur, physical and chemical. Physical weathering is when a rock is broken down by physical processes like falling off a cliff or being broken down by the wind. You might be wondering what chemical weathering is. Well, chemical weathering is simply the breaking of rocks caused by chemical reactions. So how are these different? Don't they do the same thing? Good question. Chemical and physical weathering both simply break down rocks, but in very different ways. Physical weathering is all about breaking the rock, but not changing anything about it, whereas chemical weathering breaks the rock down and actually changes the rock's identity. Chemical weathering occurs when the minerals, which make up the rock, are changed due to slightly acidic water or other chemicals. Let's take a look at this cartoon. Hi, I'm Sandy, sand of course. I will tell you my journey through weathering, erosion, and deposition. I used to live as a rock not too long ago. Then, one day, a great storm came and I slowly started to weather down into smaller pieces. This was caused by chemical weathering. After months of breaking down, with abrasion from grinding against other objects and with wind erosion, one day, with the help of the wind, I was moving to a different location. At last, the wind stopped and I was dropped near an ocean. I was then cemented together with different rocks due to the help of water and dirt. Finally, after a few months, I broke down even more into smaller rocks and became sand. This was caused by chemical weathering using water. Now that we have defined chemical weathering, let's talk about the different ways it can happen. Chemical weathering happens mainly in three ways. It can occur through carbonation, oxidation, and acidification. Over time, chemical weathering can produce big changes in rocks.
Water can cause chemical weathering by dissolution of carbonate rocks. Carbonate rocks are composed of carbonates, which can be dissolved when they are in contact with acid. Some places in which you can find dissolution of carbonate rocks are caves, as you can see in this image. Chemical compounds in dripping water build up over many years these interesting structures. Stalactites grow down from the cave ceiling, while stalagmites grow up from the cave floor. It's easy to remember which is which. Stalactites have a T for top, and stalagmites have a G for ground. Oxygen is an abundant chemical element in the air, and it is what we breathe. When oxygen reacts with rocks and changes it, that process is called oxidation. One example of this type of weathering is rust formation, which occurs when oxygen interacts with iron to form iron oxide, which we know as rust. Rust changes the color of the rocks and makes them fragile, so the weathered rocks become more susceptible to breakage. For example, in this image, you can see red rocks. This is because these rocks were oxidized, and that is why they have a reddish color. Have you ever seen an old rusty car? Well, the iron in the car was exposed to oxygen in the air and became oxidized.
The third type of chemical weathering is acidification. Acidification as chemical weathering occurs when humans undergo processes such as the burning of coal and fossil fuels. The burning of coal and fossil fuels releases nitrogen oxide and sulfur dioxide into the air and causes rainwater to acidify, as shown in the diagram. The acid rain landing on rocks causes rock surfaces to weaken, soften, and then break. Additionally, Acidification can be caused by some living organisms. Now, I know what you may be thinking. Wow, there are cool organisms that can spit acid. The answer is yes. And although they are not as cool looking as Pokemon, organisms such as lichens are able to generate weaker acids and expel them onto rocks, also helping them break down. This is an interesting example of a physical organism causing chemical weathering. Chemical weathering has many effects, and as we now learn, chemical weathering weakens rocks and causes them to break into smaller pieces. A negative effect of chemical weathering and the weakening of rock surfaces is landslides, which is the massive sliding of rocks down a hill, which can cause damage to homes that are in the way. While chemical weathering may be mean at times and make your bicycle chain rusty, it is also very helpful to humans and animals. Chemical weathering is important for many reasons. One major reason chemical weathering is important is because it helps break down rocks into soil, which we can then use as a foundation for growing plants, vegetables, fruit, and many other things to help us grow big and strong.
All right, let's do an experiment to show what chemical weathering looks like. For this experiment, you'll need water, distilled white vinegar, clear plastic cups, markers, and chalk. Hi everyone, today we're going to be looking at how chemical weathering happens when you put chalk in water and vinegar. Right here I have a cup filled with vinegar, that's what the V is for, and here we have a cup filled with water. And I have 2 pieces of chalk right here. Let's put them in and see what happens. Instantly you can see that there's bubbles being produced from the reaction with the vinegar, whereas the water, not as much is happening. That's because vinegar is an acid and it's reacting with the chalk to dissolve it. And if we listen closely, we might be able to hear it. Notice how the vinegar in the reaction is happening really fast compared to the water. That's because water is not very acidic, so not much is happening. But the chalk is almost completely dissolved after less than 1 minute. And if we leave this for longer, we get a product that looks like this, where this chalk is still mostly intact and the chalk in the vinegar cup is completely gone and the solution is brown and mucky. Wow, we talked about so many things. Let's review. We learned that geology is the study of the earth and its processes, which is important since we live on Earth. We defined chemical weathering as the breaking of rocks by chemical reactions. Wait, how does this happen? That's right, there are 3 ways chemical weathering can occur: carbonation, oxidation, and acidification. Oxidation is when oxygen in the air or soil reacts with the minerals in the rock. Carbonation is when water and carbon dioxide react to make carbonic acid, and acidification is when an acidic compound reacts with the minerals in a rock to dissolve or change the composition. We discussed the importance of chemical weathering and being able to identify it in our lives. Chemical weathering is important for soil production and growing crops. Isn't that cool? Now that you know what to look for and how to identify it, see if you can find examples of weathering around your neighborhood or school. Maybe you will find something really cool and become an earth scientist. Thank you for listening and stay curious.